So this is an airline overbooking problem in which we have a plane that can carry 190 passengers. Experience shows that 87% of the people who buy tickets show up. N is going to be the number of tickets that we sell. That's going to be like the number of people that we're polling, where 87% of the people that we poll show up. So the number of people that show up has to be less than or equal to 190. If more than 190 people show up, the probability that 191 people show up, plus the probability that 192 people show up, and so on, up until the probability that n people show up, that we want to be about 5%. So we don't know what these probabilities are. We don't know what n is. So what we're going to do is we're going to use our area model, where n is the number of tickets sold, which we don't know. P is going to be this probability that they show up, 87%. And using those two numbers, we can use the area model to approximate these probabilities and set that approximate value equal to 0.05. So remember what happens with a certain n and a certain p. We can create a binomial model, and we want to find the probability of 191 people showing up, plus the probability of 192 and 193 on up here. We're going to use the area model for that, so we're going to use these rectangles, and that means that the x-coordinate here is going to be 190.5. If I want this area to be 5%, I can take that 190.5 and translate it to the standard normal curve, because on the standard normal curve I can figure out exactly what z-value gives you an area here of about 5%. So we can do this two different ways. We can look up on our table, and we know that if this is 5% over here, we know this area here would be 45%, so we can look up 0.45 in the body of the table and go in reverse and find this is about 1.645. Or we can also use inverse norm, and inverse norm needs the area underneath the curve here, which if we know that's 5%, I know that's 95%. So this z-value should be the same thing as the inverse norm on my calculator of 0.95. I'm going to do that in my calculator to get this z-value. I'm going to take this 190.5 and I'm going to translate it so that it looks like the z here. Remember, that entails subtracting m and dividing by e. So m is going to be n times p, so m is n times 0.87, and e is going to be the square root of n times 0.87 times 0.13. So those are the two values I can just plug in here. I'm going to get 190.5 minus that divided by that. They're going to have n in them, and I'm going to set it equal to this number, which I said is about 1.645. So in order to solve that, you're going to use your calculator. So in the calculator, we're going to take 190.5 minus m, which is this, n times 0.87, divided by the square root of n times 0.87 times 0.13. And I put that into y1 of my calculator, I put that into y2 of my calculator, and if I solve for n, or x, then I will have the approximate number of people that I need to sell tickets to in order to make this curve shape such that that's about 5%. So this from here is pretty much calculator. In the calculator into y1, I'm going to plug this. Instead of n, I'm going to use x. Need parentheses around the numerator. 190.5 minus 0.87x, and parentheses, divided by square root of x times 0.87 times 0.13. That is my y1. Into y2, I could either enter 1.645, or more exact, I could just enter inverse norm right there. So I can do second vars, which is the distribution menu. Inverse norm is number 3, and I put 0.95 in there. Remember, 0.95 represents the area to the left of z, and that is that y value. I want to figure out what kind of window is going to contain both of those. The x is the number of tickets that I'm selling, which has to be more than 190. So I'd like it to be at least 200 something. So when I set my x values on my window, I want to have my x max at least, I'm going to go to 250. If I don't see it, I might have to make that bigger, but hopefully that'll work. My y value, I need to be able to see this 1.645 number. So I can set that as long as I can see that in between there, that would work. I'm just going to go between 1 and 2. So now when I hit graph, I'm not too worried about seeing the entire graph. I just want to see where they intersect. That is the 190.5 minus x times 0.87 divided by that square root. And then the horizontal line, the inverse norm 0.95. So I can do second calc intersect. First curve is 1, second curve is 2. Guess is close enough. And it gives me an n value, x value there, of about 209.75. 209.75. Now, if the directions, as they do in this case, say we only want to bump people about 5%, if I rounded that 209 up to 210, that would be about 5%. Some of the problems say we don't want to bump people more than 5%. Now, if I round that up to 210, the more tickets you sell, the more likely it is to bump somebody, which means that we'll bump somebody a little bit more than 5% of the time. If I want to bump somebody less than 5%, we would always have to round this number down, even if this is 209.75. But in this particular problem, since we're just about 5%, we can just round that to about 210 tickets sold, and that is your answer to this problem.